Hello, we are discussing about GATE 2010 ECE paper. A unity negative feedback closed loop system has a plant with a transfer function of 1 by s square plus 2s plus 2 and a controller in the feed forward path. So, in the feed forward path we have two blocks, one is G of s, the other is controller GC of s. For a unit step input, the transfer function of the controller that gives minimum steady state error. Which transfer function of controller will give minimum steady state error for a unit step input? That we need to find out. Okay. So if you observe, this is the diagram you can think. So this is controller GC and it is G of s. Both are in feed forward and unity negative feedback system. Okay. So this will be Y of s and this is R of s. So this is a system given and it has given G is given and GC is we are going to find out to get the minimum steady state error. Okay. We know for a second order system with unit step inputs, steady state error ESS is going to be equal to 1 by 1 plus Kp. So steady state error is going to be inversely proportional to Kp. So okay, as Kp is going to be large, then steady state error will be small. So whichever value is going to be yielding larger value of Kp, then the steady state error is going to minimum for that controller. Where Kp can be calculated, limit s tends to 0, G of s, G into h. The meaning of G is product of total forward path gain. Okay, h is nothing but feedback path gain. So here G is going to be replacing with GC into G into h. Here simply G means it is not only consisting of a transfer function of plot, it is also consisting of a controller. So you must replace now with GC into G. Okay. So total forward path transfer function into feedback path transfer function. Feedback is unity feedback, so h is equal to 1. So h will be 1, so it will be equal to GC into G only. Now this will be equal to, this is GC transfer function and G is also including. So let us assume s is substituted. Then what happens? S tends to 0. GC into, for G, substitute s is equal to 0. This will become 0, this will become 0. So what you will get is 1 by 2. So simply it is equal to 1 by 2 times of limit s tends to 0 into GC. Okay. So for these answers, simply substitute s tends to 0. Okay. Then multiply with 1 by 2. That will be giving the Kp of that system with controller. So we will calculate Kp for each. Whichever Kp is going to be larger, that will be the right answer for the controller. Okay. So now limit s tends to 0. As you are going with s tends to 0, the value for this one is 1 by 2 and into 1 by 2 you have to make because for Kp. Okay. So you are going to use this equation. Kp is equal to, so this will be 1 by 2 into 1 by 2, which is nothing but 1 by 4. And next, as s tends to 0, okay, you must multiply with 1 by 2. So this is 2 by 1, 2 into 1 by 2, which is nothing but 1. So Kp value is 1 by 4 for A, and for B it is 1, and for C we will see. For C, s tends to 0 and multiplying with 1 by 2. So this is s will be 0, s will be 0, 0. So this is 1 by 2 into 4 by 3, that is 4 by 6 into 1 by 2, which is nothing but 2 by 6. And GC of s for this one, as s tends to 0 multiplying with 1 by 2. So s tends to 0, this will become 0, this is 1 plus by 0, this will become infinite. So infinite into something, whatever you say, that will be infinite only. So GC of s, that is Kp for this one, Kp for option D is giving infinite. So ESS for Okay, option D is going to be 1 by 1 plus infinite, which is nothing but 0. 0 steady state error results for the controller if you choose GC of S is equal to 1 plus 2 by S plus 3S. So the right answer for this question is D. D is the right answer. That gives the minimum steady state error, that is 0 steady state error, as Kp is tending to infinite. Okay, thank you.